Hey, this is Mr. Kingsbury, and I just wanted to briefly go over how one might solve an equation using factoring. Now, the truth is that the only types of equations we can solve directly are linear ones. That is, ones where we don't have any exponents larger than 1. So for any other equations where there are exponents larger than 1, the first task is to break that down into much smaller linear bits. One way you can do that is factoring. So let's see, before I can explain the factoring part, I need to tell you about something called the zero product property. Here's how it works. It says if the product of two things is 0, then one of those things is 0. And you guys know that. You've done that for a long time. If I ask you what 5 times 0 is, you can tell me 0. If I ask you what 4,842 times 0 is, you would tell me 0. You know anything times 0 is 0, right? 5 times 0 gives you 0. 15 times 0 gives you 0. Negative 137 times 0 gives you 0. And let's just take it one step further. Let's do, like, say, z times 0. That gives you 0. Or if I had, say, 8y cubed times 0, that gives you 0. That's the power of this thing. So if there's something that I don't know, for example, if I had, this is just a brief example, let's say that 5 times x equaled 0. Some of you would look at this and say, well, this is times. The opposite of times is division, so I'll divide both sides by 5, and 0 divided by 5 is 0. You would be 100% correct. The zero product property is simply a mathematical way of stating that, and it kind of lets you shortcut it by saying, look, 5 times something equals 0, therefore the something must be 0. That 5 times x is 0, therefore x must be 0. Now, what we're going to look at are some examples where things are a little bit more tricky, like this. What if I said x times y equaled 0? Well, you know one of those has to be 0 in order for this to work out, but we don't know which one it is. So either x is 0 or y is 0. And that's the gist of this. Now, you're not going to be asked to explain that or repeat that back or anything like that, but you should know the property that you're using to solve the equation. So it's actually a pretty easy methodology here. Step 1, so for solving, here's our solving steps, right? Solving steps. 1, get everything on one side. We want that because it needs to be set equal to 0. And I'll put that in parentheses. The equation must be set equal to 0. Very important. Step 2, factor. Step 3, set each factor equal to 0 and solve. Pretty straightforward. So let me see if I can give you a few examples here. And I'll start with the simple and we'll work towards the sublime. So example 3, let's say that I gave you, I'll just keep this pretty straightforward. Let's say that I gave you well, I had some all set out in my mind, but now that I'm thinking about it, it seems like there are other ways. I want to add to my original statement that you would use factoring when you have more than one exponent in an equation. What I mean is, if I gave you an equation like, say, 5x squared minus 20 equals 0, you wouldn't use factoring on that. You would be making that unnecessarily complicated. There's only one x variable in there, and it has a squared. You can solve that. So I think my original statement was probably false. I apologize for that. You wouldn't use factoring on this. What you would use is factoring on something like 5x squared plus 10x equals 0. Notice that there's an x with a squared and an x just by itself. So when you start to have the same variable but with different exponents, that's when you might want to consider factoring. So what I would do here is go back to something we learned earlier today, and that is the factoring out of the greatest common factor, all right? And the reason for that is I don't have a third term. If I had a trinomial, I would probably then factor it a little different. But because both of these are divisible by 5 and both have at least one x, what I can do is factor that 5x, if you will, out. Those cancel. Remember, whenever we have something the same top and bottom, it cancels. That cancels. X squared divided by x is x, and 10 divided by 5 is 2. So what I get is 5x times x plus 2 equals 0. So that's step 1. Get everything on one side. That was given to us. Step 2, factor, check. Step 3, set each factor equal to 0 and solve. That's the last bit. It's pretty easy. If we do 5x equal to 0, and then we've got x plus 2 equal to 0, we'll solve each. Here I have 5 times x equals 0. The opposite of multiplication is division. So I will divide both sides by 5. 5 divided by 5 is 1. 1 times x is x. 0 divided by 5 is 0. So x equals 0 there. On the other side over here, I've got x plus 2 equals 0. The opposite of adding is subtracting. So I will subtract 2 from both sides. 2 minus 2 is 0. X plus 0 is x. On the other side, 0 minus 2 is negative 2. So I have that x equals negative 2. You might notice, by the way, that our exponent, our biggest exponent, was a 2, and we have 2 answers. That is not a coincidence, my friends, not in the slightest. All right, let me give you a couple more examples, and then we'll call it a day. I don't want to overload you, but you're going to want to be able to factor quickly and solve. This is an important skill, so it's important that we do more than one of these. And of course, there will be extra practice and so forth added in there, so do not worry. Also, I don't know if you noticed, but I'm down to my last sheet of paper, so that makes this crisis important. Well, I guess crisis is enough to show that it's important. Anyway, all right, so I showed you one where we just factored out a monomial, and then what I want to do is do 2 more where we're factoring something that's a little bit bigger, and go from there. And then your teachers will add onto that into class, I think. So let's say that we have, let's see, something like, I have some problems picked off to the side, and they're not working out for me, truthfully. Well, my goodness. Well, what I want to do is have one where there's a number out in front. Give me a moment. I'm going to select a problem here. How about, oh, I went to the wrong thing. Here, let's try. Ooh, I like this one. 3x. And that is going to equal negative 4. Step 1 is get everything on the same side. Since I have the x squared and the x already on the left, I'm going to go ahead and move this negative 4 over. We do that by adding 4 to both sides. On the right side, negative 4 plus 4 is 0. That's what we want. We want it equal to 0. On the right, or the left side here, all I can do is rewrite 3x squared minus 8x plus 4, because none of those things are like terms, so they don't combine. The next thing is I need to factor this. And you may remember that you just learned how to factor, should say just learned, you were just reminded how to factor a trinomial into two binomials, right? So first we have to figure out what A, B, and C are. Looks like my A is 3, my B is -8, and my C is 4. Okay, fair enough. Off to the side, I'm going to write a little something here. I'm going to multiply A and C. So A times C would be 3 times -4, which is -12. And as I mentioned, my B is -8. So I need two numbers that multiply to -12 and add up to -8. Now, there's lots of ways to do this. I'm not a huge fan of people that like to just say, okay, just think of them like they're going to magically come to your mind or something. I like to provide kind of a way, a method. So what I do when I want to find my numbers is I write out all the things that multiply to 12. I'm not going to worry about the negative right now, but I'm going to write out all the things that multiply to 12. So 1 and 12, 2 and 6, 3 and 4. And notice I did that in a real organized way. I started with 1. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. And it made them in order here on the left side. And then on the right side, they're also in order, but going backwards. So 1, 2, 3 on the left, 12, 6, 4 on the right. They're starting large and getting smaller on the right, starting small and getting larger on the left. That helps me keep organized, and it helps me to understand that, not understand, but it helps me to not miss any. The other thing is, remember we said that our B was equal to -8, so I need these to add up to -8. But right now, none of these add to -8 at all. And some of you may be able to look at these three and go, I can figure out which ones add up to 8 and how to adjust their signs. I want to go through and be real methodical for you. So right now, none of these, not only do any of these not multiply to -8, but none of them actually, sorry, I said that wrong. Right now, none of these add up to -8. Also, none of them technically multiply to -12. We need them to multiply to -12. That's important. And I feel like I did something wrong because I don't think this is going to work out. Oh, it's not -4. I'm sorry. C is +4, so this should be +12. Okay. So these all multiply to +12. I apologize for the error, but they don't add up to -8. This is the methodology that I use. When you add things, the sum of those things is always equal to whatever the largest thing is that you're adding up when you're adding two things. All right. So if I were to add two negatives, I'm going to get a negative. If I add two positives, I get a positive. If I add one negative and one positive, whichever one's bigger, that's going to be the sign of whatever I'm adding up to, right? Like if I added 12 and -1, if the 12 was positive, I would get a positive number. Think of it like this. If you have more money in your pocket than you spend, then you're left with money in your pocket. If you spend more money than you have, which is possible with a credit card, then you end up owing someone. It's that kind of deal. So I know that when I add these up, I'm going to get a negative number. And I know because of the rule I just shared you, that means the larger one in each pair, which is all on the right side, they all have to be negative. That's what that rule says. When you add two things and you get a negative, the bigger one has to be negative. The other one could go either way. Then I check it. So if I multiplied 3 and -4, do I get +12? I don't. And once you've made that adjustment of the sign of the larger number to match your sum, if you multiply and you don't get your product up here, then you need to change the sign of the other one. Now, if I were to ask you which of these added up to -8, I bet you could tell me really quickly. -1 plus -12 is -13. -2 plus -6 is -8. -3 plus -4 is -7. It looks like it's this one. So here's what I'm going to do. I'm going to rewrite this as 3x squared, and instead of -8x, I'm going to put in -2x and -6x. And then I'll put my +4 on the end, and that equals 0. And the rest of this then is really, really simple. I'm going to group these two, and I'm going to change this. I'm going to make this plus -6x. I'm not a fan of putting a minus here because I'm going to group these, and if I don't group it correctly, if I don't leave that sign attached to the 6, then I've messed myself up, and I won't be factoring correctly. So I'm going to factor out the GCF of this first group. It looks like 3 and 2 have nothing in common. That's a bummer. But they do have the x squared and the x have at least one x in common. So I'm going to factor that x out. 3x squared divided by x is 3x. These x's over here cancel. I'm left with minus 2. Then I'm going to put a plus. And then I got to figure out what these guys have in common. Well, they don't have any x's in common, but 6 and 4 definitely have a 2 in common. So that's good. The other thing I want to look at is the first term of each group. Notice that they have opposite signs. When that happens, I want to make this number I'm factoring out negative. Trust me, it's going to work. So I'm going to factor out negative 2. Negative 6x divided by negative 2 is 3x. 4 divided by negative 2 is negative 2. So now I've factored out an x and a negative 2. And notice what's the same here. 3x minus 2 is the same in each of these groups. So I'm going to factor that out. It's like factoring out a super term. So I get 3x minus 2. And after I factor that out, what's left here in this group is an x. So I'll open another parenthesis, put an x. And what's left here in this group is a negative 2. So now I factored. So let me review here. I took 3x squared minus 8x equals negative 4, set it equal to 0 by adding 4 to both sides. And now 3x squared minus 8x plus 4 equals 0 has been factored into these two factors, 3x minus 2 and x minus 2. From here, all you have to do is set each of these equal to 0 separately. So let's start with x minus 2 equals 0. That's the easier one. So we're going to start with that. X minus 2 equals 0. To solve that, you add 2 to both sides. Negative 2 plus 2 is 0. X minus 0 is x. On the other side, 0 plus 2 is 2. So one of our answers is 2. Then we set 3x minus 2 equal to 0. Again, I will add 2 to both sides. Negative 2 plus 2 is 0. 3x minus 0 is 3x. On the right side, 0 plus 2 is 2. And then that leaves me with 3 times x equals 2. The opposite of times is division. So I will divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. That's on the left. On the right, I have 2/3. I'm going to leave it as 2/3 because I know that's a messy decimal. If, however, you want to write it as a decimal, I would suggest you write 0.67. Either of those is going to work beautifully. So I wanted to show you that. Let me do one more, but this time I will do one that is actually a little bit simpler, and you'll see why. Let's do, I already used one with 8, so how about, ooh, I don't like that one. Ooh, I like that one. Let's do, here's my example. Example 5, last one for the day. I apologize, this is going a little bit longer. I tend to talk a lot more than I should, but I do it. I'm sorry. Let's do, I just had it, x squared. Do I want to do that? I wanted more minus signs in it. Yeah, x squared minus 7x. Wait a minute. I meant just minus x. My bad. X squared minus x minus 90. You guys are going to love that. Okay, actually, let's do it like this. X squared equals x plus 90. And I did this on purpose. First of all, we need to put everything on one side or the other. I'm going to suggest a lot that if your quadratic term is positive, you leave it positive. So basically what I'm going to say, what my suggestion to you is since this is a positive quadratic term, move the other two over by subtracting x and subtracting 90. And remember, none of these are like terms, so you can't actually combine them. I am sure that one or two of you wanted to put this x squared and x together and tell me that x squared minus x is 0 or something like that. It's not the case. These are not like terms. Their exponents are different. So now we got everything on the same side. My a value is 1. That's the coefficient of x squared. Remember, if there's nothing there, we assume it's 1. My b value is going to be negative 1, because there's the negative, and my c value will be negative 90. Now let's go off to the side and do our factoring thing. And I'm worried that you're not going to be able to see, so let me move my paper up here. So a times c, that's going to be 1 times 90, negative 90, which is negative 90. And I'm going to write out all the things that multiply to 90. 1 and 90, 2 and 45. 90 divided by 3 is 30. 90 divided by 4 doesn't work. 90 divided by 5 does, though. It ends in 0, so it's divisible by 5. That would be 1 and 8, 18. 6 goes in there. 90 divided by 6 would be 15. 7 doesn't work. 8 doesn't work. 9 does, though. 9 and 10. Notice these are right next to each other. That's how I know I'm done. Then let's make some adjustments. My b value is negative 1. A negative sum means the right column is negative. Now, if I were to multiply, say, 2 and negative 45, would I get negative 90? Absolutely. So I don't need to make any more sign changes, which is great. I just need to figure out which of these adds up to negative 1, and I believe it's going to be 9 and negative 10. So I'll go over here, and I'm going to rewrite x squared minus x minus 90 equals 0 as x squared minus 10x plus 9x minus 90 equals 0. And some of you may go, why did you swap the negative 10 and the positive 9? If you'll remember up here, when we rewrote it right in this area, because there was a minus here in the middle with that third term, I went ahead and changed this from minus 6x to plus negative 6x. And I did that because having that negative there creates an issue. By switching them down here and putting the positive one right here, I have not adjusted my problem at all. It's still going to work out beautifully, but I've saved myself the headache of dealing with that negative. So it's just a little trick that I learned. Whenever you have a positive and a negative factor, put the positive 1/3 and the negative 1/2. So here are my groups: x squared minus 10x, 9x minus 90. First group, the only thing they have in common is an x. So I will factor that out. X gets factored out. X squared divided by x is x. These x's cancel. This is really just negative 10 times 1. That's negative 10. So I get that. Over here, I got 9x and negative 90. They certainly don't have any variables in common, but they do have the 9 in common. 9 divided by 9 is 1. 1 times x is x. Oh, sorry. I forgot. I need to put what I factored out first. So 9 goes there. Then we got an x. Uh-oh. I think my pencil may be giving out on me. I'm really hard on mechanical pencils, unfortunately. Times x. And then negative 90 divided by 9 is negative 10. And that still equals 0. And here's how I know I did it right. The binomial inside the parentheses is the same. So we're going to factor that out. I get x minus 10. And what's left in the first group is x. I've opened my parentheses, x, bring down the plus. What's left in my second group is a 9, and that still equals 0. So now I have x minus 10 times x plus 9 equals 0. And all I have to do is set each of those equal to 0 separately, and I'm good to go. So let's do that. X minus 10 equals 0. X plus 9 equals 0. And let's solve that. X minus 10 equals 0. To solve that, I would add 10 to both sides. I get x equals 10. Over here, x plus 9 equals 0. I subtract 9 from both sides. I get x equals negative 9, and I've solved them both. So that's how you do that. There should be some more practice going for you on later in class and provided for you and so forth. So good luck.